streaming.
Okay.
And yo.
Can we have an estimate of when we can see our percentage?
No.
Or our proficiency?
No. Because I'll just disappoint you. And I feel bad then.
Oh.
A little. Not too much, but a little.
Wait, actually?
Yeah.
What do you mean? Why
Do you actually feel bad?
If I disappointed you? A little.
No, I mean if you give us like a really bad grade.
Oh, yeah, always.
Really?
Yeah.
I studied for so long for the
Yeah.
test, and
I-
lots of grade was disappointing.
Yeah. In fact, I'll probably not release it to you until I'm in the class to talk about it.
Why do people do badly?
Some people always do badly.
Then why would
Some
you?
people always do well.
Why would you have to talk about that?
He's waiting
Check the
because he
back.
wants people to be able to ask questions if they did that.
Oh, why is your phone?
Oh, I did it.
Is it not there? There's literally a huge stack of them somewhere in the classroom. Oh, they're like right here. There you go. No. I just like those arrows. Okay. You're coloring.
I just need to learn.
Oh,
Because I just saw 3D.
Zoom, entire page. Get your attention. Laptops away. Luca, Taylor. Laptops away. NA. Luca. Eshwan, stop talking to Luca. Put away laptop. Okay, which should be the brightest?
The middle low.
0.5 molar.
There we go. Bright. What one should be dark?
Like off or dark?
Like no light.
The two on the right.
Two on the right. So darkness will be represented by the best Ms. Walensky's color.
Yeah.
Color it in.
You don't have to color it in. I am, just to emphasize the point. Because are light bulbs really emitting light? Or maybe they're just darkness suckers. When you turn the light on, the reason it's so bright there is because it's sucking away the dark. It's lightest around the light bulb because that's where the least dark is.
No.
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 Why not?
No.
Yeah, could be.
Because science.
Trust, hey, hands up to your chemistry teacher. Oh, looks like I win every argument. Okay, which is the next brightest?
One third left.
Left? Yeah, so a couple more there. And then the next brightest after that? Yeah. So what I'm going to emphasize is that the HCl is a strong acid, and even at a lesser concentration, it is a strong acid. For acids and bases, the word strong does not indicate their strength. Their strength has to do with how much they dissociate. So they have one-way arrows. Whereas citric acid has two-way arrows, so it is weak. Not 100% of it is dissociated. Darkness suckers. And in prep, you'll probably want to get out your table and turn to that page. Relative strength of Bronsted-Lowry's acids and bases. We won't be using it just yet, but you should have it available. All the definitions, we've already done electrolyte. What defines, laboratory-wise, what is an electrolyte? What does it do?
Wait, Mr. Jones.
Nope, tell me what electrolyte is.
It's it conducts electricity.
Excellent. Now your question.
With the lights that don't turn on, is that a base? Or is that just like
Ooh, no.
wait.
The ones that don't turn on are a,
Disassociated. Oh, non-electrolyte.
yeah.
Okay. But it's still acid.
And When I say conducts electricity, I'm not talking about like a metal wire. This has the hidden end of the sentence that I'm not putting on because it would make the sentence too long, is conducts electricity in a solution. So we're not talking wires, we're talking in a solution. Maybe I should put that. I'll just make it abbreviated. In solution. I'm actually going to define two terms here. There's dissociated and there's ionized. These are both chemistry 11 terms. What do they mean? They're very closely related. They mean almost the same thing. The hint would be ionized.
One of them doesn't have any ions, and the other one is having ions when it's separated.
Yeah, well done. Ionized has ions and it separates. So you get NaCl goes to Na plus Cl minus. Has ions, has ions, has ions that separate. Except, I just realized, ionized. That is dissociated. I ruined my own example.
Bro.
If you already have ions, you're dissociated. But if you don't have ions, then you become ionized.
Wait, what does
Right.
it say
Now I've
after
got it.
the NaCl thing?
So the NaCl is under the dissociation because it has ions.
So has ions
Something
that
Has ions that separate.
ask the computer.
No,
Yeah.
no, I'm definitely not asking you to do
Ask
that.
it.
Computer.
Fine. Oh, it's all individualized. We're all individuals, yes, just like everybody else. Has
What
ions.
about the other two?
Nope, I think we're good with that one.
No, I want to see what the A says. I want to see if that
Oh,
was
the
that.
little thing is, okay, that,
No,
oh,
literally leave it like that.
Okay.
that,
Just confuse everyone.
that,
So now if we go back to
Group. Group. that, separated. Ah,
Okay.
yeah,
Where's the brackets though?
we can't have everything.
It's not like equilibrium.
Yeah. Ionized. Give me an example of something that is not ionic, that definitely has ions in water.
Sugar.
There's sugar in water. You drop it in water, it goes to
Use your finger. It works better.
AQ. Sugar stays sugar. Sugar is sugar. It's like math is math. Doesn't change. Yes, Nicholas.
HCH3CO.
Oh God, yeah. Give me an easier one without a big formula, like the one that's in your stomach. HCl. HCl. HCl, ionic or covalent. Covalent. It doesn't have a crystal structure. It doesn't repeat forever. It is definitely covalent, but its bond is so polar that in water it will go to H plus Cl minus.
It doesn't say AQ.
This ionizes. So it becomes ion.
Wait, is HCl a solid or is it?
I made it a gas, so we're bubbling it through solution. Because that's one of the ways you generate HCl.
Wait, so it's different than dissociated?
Because of your starting point only. So dissociated is for ions, ionic compounds. Ionization is for things that aren't ions that become
Covalent
ions.
compounds, basically.
Pardon?
It's for covalent compounds,
For covalent compounds.
and then dissociated is ion.
These are ionic compounds. And you will hear every teacher, textbook, Mr. Neufeld confuse these two terms. Because both of them means it's becoming ions. So if you say, oh, this ionized, I may correct you. or I may not, and just accept the fact that we both know it's coming to ions, because it's a little pedantic. It's pedantic in a way I don't strongly care about. But it's important to know, it's like the difference between atomic mass and mass number. One's an average, one's the other one, but half the time nobody cares. The main thing is if you have ions, you can conduct electricity. So, how did we know that HCl was a strong, how do we didn't see the dissociation, how do we know in the lab? Like, how do we know electricity passed through it?
There's an ion.
The light lit up.
Light, bright.
Yes.
And the reason I was being pedantic about that is because things like, because it conducts well, you can't, those aren't things you can observe. We're always making inferences, and all those are inferences based on the observation the light was bright. There could be other reasons the light was bright. It is entirely possible that you could have such a weak solution of HCl that you thought it was a weak acid, which is why you would have to calibrate it, make it a certain concentration, and then test it. So our observation the light was bright, it must be a strong electrolyte. Vinegar was incredibly weak, to the point we didn't even see it light up. With the other class, I actually did it in the classroom. We turned off all the lights, and we could barely see it. And I even recorded it, although apparently it was very bad. So I didn't even know if you could see it from there. So it's a weak electrolyte. Very little light. That's his light. Doesn't ionize well. And the strong electrolyte has 100% ionization. Strong, highlighter, green. Strong is 100%. Weak is just less than 100%. It's like your effort. If you're giving 99%, you're weak. It's 100% or nothing.
What about 100?
Early is on time. Late is just late forever. Doesn't matter 1 second, 2 seconds, 10 minutes, you're just late. On time? On time is late.
What if you're,
Because if you're right on time, you're late.
how so?
You're always late. Because you walked in the door that time, the clock just ticked past, you weren't actually on time.
Oh, so you weren't like at
But
your
what if
desk
You weren't
with
at your
stuff?
desk.
The
Yeah.
exact
You
moment.
sit
No,
down.
no, these are pedantic arguments. You're late.
No, but.
No, you're just late.
No.
Because when you're because I have listened to a student do this, and they're like, no, I submitted it right at midnight. It was on time. And the person at the other end says, I don't care. The computer didn't accept it. I don't have to accept it. Too bad. On time is late. Always be early, because early is on time forever.
Is that why the Earth is flat?
The earth is flat because it is flat. But we're not going to do that because you're confused.
You're confused.
Well, you are. You've been lied to your entire life, and once I expose the general truth to people, they tend to get upset, not knowing the huge favor of doing them.
Mr. Neufeld, what if the class or like the school got enough funds together to go on the the Virgin rocket that they have, like
Yeah.
Virgin Galactic rocket?
Yeah.
What if this school funded you to go there
Yeah.
and then take photos and prove that it was wrong?
But I believe the photos.
What?
I believe the photos. Like I don't understand your point.
But what if you're the one taking the
Like, what if
photos
you're
and
the
you
one
see
taking
with your own eyes that it's not flat?
Hold it. Why wouldn't I believe that it's flat after seeing the photos? Like I don't understand your point. What would that prove?
Like that's
No, the earth bends, right? What's a black hole?
basically
Something where light.
A black hole is a center of gravity with gravity so intense that
Light can't escape.
light can escape. As Einstein stated, you've heard of physics. You know from that example, even if you hadn't heard before, that light always bends in a gravitational field. In fact, we actually use that gravitational lensing when we're looking at things really far away because it helps focus light that is really far away. So we can use whole galaxies as a type of lens to view light from behind them. We do this all the time. Light bends the gravitational field. Question for you, Felix. Does Earth have a gravitational field?
Yeah.
So would light bend in it?
Yeah.
So would it
No, it's
appear
not
round
like-
from space?
No, but like.
No, it's
In
not
fact,
like, you know.
in fact, when you're right on the Earth,
One of you.
when you're right on the Earth, doesn't it appear flat? And then as you get further away, it appears more and more round?
The gravitational field is so negligible.
Sorry, yes.
Sorry to interrupt.
No, I think we got distracted. So
I was so judged and sweaty.
I see as you're
Do you
using
see how sweaty I
screen,
was?
is
Print
there
out
any
my face
way
and
that
all.
Mrs. Lawrence can use that TV screen?
Yes.
This small?
Oh, you can. Yes, you can.
I could switch to the projector, I'm pretty sure. If she needed it quick.
Sorry,
Yeah.
it's just they're doing,
Literally just use the
they're
whiteboard.
presenting their demos.
Oh,
that's
okay.
so important.
Yeah.
And I forgot all about it.
No, it's okay. Let's just.
I wish
Steel teeth.
Now,
You have a whole whiteboard to show us how the Earth is not round.
and
always hated the TV. This one's good.
there,
The calculator.
and
I'm sorry.
there. No. I'm just making sure. I gotta do it in the right order or my computer crashes, then I'll just have to restart my computer. And I think that works. And at this point, we just have to shut down
Anything else?
the computer.
You can leave it on. Oh.
Well, when we unplug it, it'll. We should set the computer so it hibernates instead of shutting down. That would be faster when we want to restart it.
Checks out.
Yeah, I guess you.
Okay, Nicholas, move your desk. Help. I've appointed you to help.
How do things stay in orbit if it's flat?
Pardon?
How do things stay in orbit if it's flat?
What does flatness have to do with orbit?
Centripetal force.
There's no such thing as centripetal force. Ask any physics teacher.
No, there's supposed to be centrifugal force. As
You're confusing two things together.
No, I'm not.
Or I am, but I don't really care
You
which way
are.
it is.
Centrifugal force is the one that doesn't actually exist. Centripetal force does. That's why you can
Oh,
like
they need
drive
this.
really fast. How speed.
Lock the door, lock the door.
What did he say? Centripetal force
Yes.
The gravitational force is negligible. It can't affect the way light moves.
Hold it.
It'd be different
Okay,
forms.
yeah, you're just saying words that you believe, but clearly it's not negligible.
You can answer
Well,
my
how do you
question.
know that it's negligible? Or that it's not negligible? Like, how do you know that it's so?
You're literally sticking to a planet. You think it's negligible?
Yeah.
Okay.
Yeah, but light has.
I mean, clearly you're wrong, but okay.
No, it's negligible in terms of bending light, is what I mean.
Yeah, because light has no mass.
Light has no mass?
No, like can bend. That's also correct. Like never bend, but
Let's see what this is. Hold it. I gotta see. Now we've switched a whole bunch of things. I gotta see what's going on.
this feels empty and strange.
Yeah, this is doing weird stuff right now. And we got this one. Okay, while we're waiting, I want use your table. I want 5 strong acids, 5 strong bases, 5 weak acids, and 5 weak bases listed. Let's go.
Oh, that's so annoying.
How many in this series?
Exactly.
5 of each.
Be like, oh, no, that's all right now. I'd be like, why are you giving me a video? Maybe because we're dating.
It's a lack of.
What the hell?
Dylan? What are you saying, Dylan?
You know the ones that say very large?
Oh, my musical went well, by the way. She didn't get mad at me.
Who?
My musical went well. She didn't even get mad.
Whereas if there's no person.
She
Well
accused
done.
me of lying to her, though, and then I said I didn't. I just didn't tell you. And she's like, "Isn't that lying?" And I'm like, "No, it's just not."
Oh, so you argued.
What was that?
Oh, you're in so much trouble.
And she was like,
Even
don't
so
get
much trouble, you don't even know how much
no, and
trouble.
then she was like, don't get smart with me, and I'm like, okay.
That's what it goes.
And then she just changed the topic. It was actually totally fine.
Yeah.
If the costume lady covered for me, she was so nice. She's like, exactly. I know she's never had fun in her entire life. She's taking it out on me.
Okay,
Last semester,
hopefully that works.
everything except
And
the
hopefully
credit.
we are now
Except for the credit.
streaming properly. I will have to once again work from here. I can't walk up to the board anymore. I'm sad.
Strong acid.
Because I can't write on it.
H3O.
Ah.
What's the base?
Okay, what do we got? I'm gonna put some notes on the top. A strong acid
That's like way too small.
reacts completely.
You're a lot faster at writing on this than the board.
In water, yeah, it's a little easier, to form an aqueous solution, 100% ionized. I haven't done tense. I'll quickly do that now, and then I'm just going to ask you. We are block A, and Anae's here, Dylan's here, Eric's here, Ashwin's here, Felix, James, Chloe, Luca, Luce, Nicholas, Sabine, Sophia, Taylor, and Teddy. We're all here. Okay. Actually, why don't I just go around the room, starting with James, who's on his phone. Give me two strong acids.
HCl and
Where's your data table?
I just don't know how to memorize it.
Go get, no, you need your data table out. How did you fill out any of the other columns?
HI is the other.
HI is another one? Okay, let's keep going.
HNO3.
HNO3. I want two in total.
H2SO4.
H2SO4 is another one. Let's go back, Felix.
HBr.
I need two.
HClO3. O4. HClO4.
HClO4.
Yeah.
Okay. And of course, everybody is looking at this, and they're filling out these. These are the strong acids, and the reason we know that they're strong acids is because they have one-way arrows. They only go that way. These are the conjugate bases of the strong acids, and they are so weak as bases that they're not bases. They could never accept a proton because they're on the wrong side of a one-way arrow.
What are they considered?
They are conjugates of a strong acid. They can't act as a base. So they're not a
What
base.
pH they have?
They don't. That's what not being a base means. Like if you add sodium iodide to a solution, the iodide does not change the pH on its own. But again,
Conjugate acids?
pardon?
They're conjugate acids,
No, this is the base side.
but they're conjugate bases.
They're conjugate bases. They're called that because they are the conjugate base. But they're so weak, they don't do anything. Okay, keep going. Na, give me a strong base.
Wait, is HClO4 a strong acid?
NH3 is not a strong base.
Wait. Mr. Newfeld.
Nope. I'm talking in Na right now. You got NH3 by looking down here. But what is this side labeled? Acid. So notice it says strong there. Go all the way down here. strong there. What are the two bases?
H plus NH2 minus.
No. I just need the base. H plus is like a soup is acid. So it would never be that.
H2 minus.
Pardon? O2 minus, that would work. O minus 2 and
NH2 minus.
NH2 minus. Excellent. Then we're going to pop back. Is there anybody directly behind you in it?
Well.
No. We got Eric. Give me more. I need at least 3 more strong bases. So you give me 2.
What about the C6H5O?
Nope.
Start NH2
No.
with the
Nope.
yeah.
How do we know if it's a base?
I'm so confused.
If I asked you in grade 10, you'd be able to answer this right away. The only reason you can't answer this right now is because you're looking at the table. How many strong bases are there down here? 2. But you know more than that. If I asked you for a base last year, what would you say?
NaOH.
Yeah, you did. Acid and bases.
We didn't do acid.
NaOH.
You did types of reactions. You definitely did acid and base. NaOH.
But that's all we learned last year.
Yeah, that's all you need. That's a base because it gives off hydroxide. That is a strong base because it is soluble.
It's there.
This is why we have to do the solubility unit first. Is sodium hydroxide? Is hydroxide soluble with sodium? Get out your solubility table.
NA dissolves.
Pardon?
NA's gonna dissolve.
Na.
NA is gonna dissolve.
Everything.
Yeah. So it's fine. Give me a Eric, another strong base.
KOH.
KOH. That works.
Wait, how do we know
Next.
that they're strong? I'm so confused.
Lithium
hydroxide.
Lithium hydroxide. I'll answer your question in a moment, Dylan. Go back. Eshwan.
Oh.
Strong base.
CO3.
Pardon?
CO3.
No, that's not strong. That is an equilibrium. We need 100% dissociation.
Oh, okay.
So we got NaOH, KOH, LaOH.
Oh, I have one.
NH3.
NH3.
No,
Or NH3.
MG.
no. We already said NH2.
Oh, right. I don't know, like KCO3.
KCO. No,
Why not CO3 though? Isn't CO3 strong?
no, it doesn't. Lies. Lies you're telling me. Where do you see CO3 says strong?
Down?
Down. Yeah.
Right there.
Where? No. This is on the weak half. See this right here? That's the strong stuff.
Oh, sorry.
Only the shaded stuff is strong. And only on this side for the bases. If you're on this side of the one-way arrow, those are the weakest of all. This side, super weak. So weak, it can't even be weak. It's nothing.
Oh, it's not even a base.
Yeah, it's
Or an acid.
it's not an acid. NH3 can never be an acid.
Okay.
It is the weakest of all but. But we already added NH2 minus. We already added O2 minus. And then what I said was, well, all of our hydroxides that we did last year on the Arrhenius definition of bases, they dissociate 100% because it's soluble. NaOH, 100% goes to Na plus OH minus. And so that is also a strong base because it just gives hydroxide 100%. So
Yeah.
strong base. So sodium does, potassium does. So with your solubility table, what else does?
So like anything that's not soluble.
Anything that is soluble.
Or yeah, any so SROH.
FROH would work. Look at. Oh, haven't we said? There we go. CSOH. Taylor.
RBOH.
RBOH. Sophia. Probably.
Stole it from me. It's fine, I'll say a better one.
Yep.
SROH2.
Yep. I think that's definitely soluble. So all of those. So one of the difficulties with the table
Can't stop.
is it doesn't list all the bases. It lists all of the weak bases.
I know, that was
Dylan, can you put away your phone?
I'm just changing my password.
No, put it in your bag. It doesn't list any of the metal hydroxides, so you just have to remember those are bases. Nick?
It says it only is soluble with like alkali ions, so it's only soluble with one in the very left column.
Very left column, and I think strontium for sure. I'm not sure about magnesium.
Strontium, ammonia, and hydrogen.
Okay. Yes.
So magnesium would not be.
So magnesium would not be done. Okay. Now the next one.
Wait, Mr. Newton, I have questions.
Yes.
No, like, so,
Oh,
how come, like, there's O2 minus, like, it's not, it has a charge.
Right.
Is that allowed?
Well, sure, but if you went to get it off a shelf, you'd probably go Na2O.
So it would be best if we write Na2O.
Well, I want you to know it's O minus 2. And you should know that Na2O, K2O, Li2O, all of those count. And I don't want to write every single one.
Mr. Neufeld, why did you cross out MgOH2?
That's not soluble.
And that would be the same for NH2 minus?
Yeah.
An example would be Na,
NH.
NH2.
Oh, the
Yeah.
magnesium one isn't soluble,
I don't think it's soluble.
so it's not going to be a strong.
So it's not going to be as strong. You're not going to get 100% dissociation. You're going to get a solubility equation.
Oh,
Okay.
Low.
Now, using the same
I'm not
table,
reading it exactly. No,
Taylor?
that's not amazing.
Taylor?
Yeah.
Okay. I need examples of weak acids off of that table. So using the correct side. 1. Are you able to lose?
H2O.
H2O is in fact a weak acid.
Spell that word.
H CO3. Charge? Nice. Yeah, that works. Keep going. James. Or Teddy. HF. Yep.
Oh, no, I don't. H2O.
Oh, you didn't have to keep going. That was pointing. Although I'll write it
It
down.
wouldn't be NH3. Sorry.
NH3 cannot be an acid.
Okay, so then HCO3.
Oh, we already have that one.
NH3 can't be an acid?
Nope.
Why?
We'll do that in a minute. One more.
HPO4.
No.
HPO42.
Okay. Na, give me some weak bases. Just one.
BR minus.
No. Why can't Br minus be a base? Looking at the table, why can Br minus not be a base? It goes to completion this way. Can it ever go the other way?
no.
No. So you cannot pick anything in here. These are too weak. So anything else?
HSO3.
HSO3, perfect. Felix.
H plus IO3.
H what?
Plus IO3.
That's not a base. That's a reaction.
IO3 minus.
There you go.
How
Okay.
can you remove the H then?
What?
How can you remove the H?
What do you mean? How can you remove the H?
Like, why do we remove the H?
Because it's a reaction. It's not a base.
But how do we know that H is not a base?
Because I've asked you for a base, a compound, and what you gave me was two compounds.
How do you
That
know,
is two things because it's got a plus.
How do you know IO3 is the base and it's not H?
I'm gonna have to turn that right back at you. How do you know that? Last day we worked with conjugate acids and bases. So if HF is the acid, what is its conjugate base?
F.
F minus, right? So are these bases?
No.
No. In fact, what is H plus?
Conjugate acid.
No. That's the conjugate acid. What is H plus?
Acid.
It is acid. It's a proton. It's the thing that makes an acid an acid. And these are all written as acids. So you're going to see H plus. We could have an entirely different table in which they all reacted with water and made hydroxide, and then you have a table of Kb. So yeah, don't give the reaction, don't be fooled by that. So Felix, I think you still have to give me one.
Oh, IO3.
IO3 minus. Nick,
OH minus.
that's not weak.
It's still
No,
considered.
no, no,
But it's like not.
No,
it's white.
no,
It's white.
no,
It's white.
no.
Your rules.
no. I'll explain after, but no.
Which one?
SO4 minus 2.
ASO4 minus 2 would work.
H2.
Eric, no, Eric,
NO2 minus.
pardon?
NO2 minus.
NO2 minus will work. Go back. Taylor,
Yeah. Would PO4
PO4 minus 3 would work. Luca,
SO3?
pardon?
SO3?
SO3 would work. Do we already have it? No. Now, Eshwan, I really want you to say HPO4 minus 2. Thank you. Perfect.
Wait, where is this?
Now, Eric, question?
Wait,
Phosphate.
can you use H2O?
You could use H2O.
So it's, you can use H2O for a weak acid and weak base.
Yeah, you can.
Because of.
You also can use HPO4 minus 2 for a weak acid and weak base. And if you notice, you go to the table, you can find HPO4 minus 2. Help me find it. It's on both sides. Where is HPO4 minus 2 on both sides? There's HPO4 minus 2 on the acid side,
And one on the base side.
and then on the base side,
It's down.
down.
Dihydrogen phosphate atoms.
There it is. There. So both sides.
No.
What is the name for the thing that could be both sides?
It starts with an A.
Amphiprotic. It can both donate a proton, and it has enough negative charge that it can accept a proton.
Oh, that's what you're going to explain to me the other day when I was confused.
Yep.
That makes sense.
So water and hydrogen phosphate, and there's also HSO3 here, but HSO3 could have been here too. These are amphiprotic. They can act as both an acid and a base. Same with water. Now someone said hydroxide at some point, and I think that's because you find it here, and that is because this reaction, notice it has both H plus and OH minus
What
in it.
has, when it can do both, it's antiprotic?
One second,
I didn't know.
Dylan. Someone looked at this and said, oh, I guess hydroxide is a weak base. And I want to be very clear. In the same way that you see H plus in all of these weak acids, is H plus a weak acid? No. H plus is what acids give off. And hydroxide is what bases make in water. So their position on the table doesn't actually indicate how their strength. They are just products of acid-base reactions. So water on its own, by itself, sitting as a distilled product, has a Ka of 1.0 times 10 to the minus 14, which means it will give off a concentration of 0.1, 2, 3, 4, 5, 6, 1 molar H plus solution in pure water. It dissociates a tiny bit on its own. So water is covalent, but it does ionize a little bit. And that number is very important. It's 14. And this happens to be 1.0 times 10 to the minus 14. Didn't have to be, but it was really convenient that it was, because that means our pH for neutral is 7, because that's 10 to the minus 7. And our pOH for neutral is also 7. And so neutrality is 7, not because there's no acid, but because there's a very small amount of acid that is equal to the small amount of base. And it is tiny, tiny, tiny. But pH is a measure of acidity. There is still acid at pH 7. There's 1.0 times 10 to the minus 7. If something is basic and it has a pH of 11, it has acid. It just has 1.0 times 10 to the minus 11. And the base hydroxide is 1.0 times 10 to the minus 3. It's much bigger. They both always have to add up to 14, because that's what water does. Yes?
Wait, so like, just to be clear, H plus isn't an acid by itself, it's just what acids are.
H plus is what acid is. Another way to say it is technically the strongest acid, because that is the
Wait.
thing all acids make.
Because I wrote H plus is not an acid. It's
Having the don't write H plus is not an acid. It
Oh.
is what acids make. It is what acids is. Having the debate about whether or not it's an acid is as frustrating as the conversation about whether or not water is wet. Is water wet, or does it wet other things? But doesn't it also wet itself? At some point, you can have that argument. Usually
Yeah.
with everybody who is at a very end of a long night and it's kind of pleasant. But really in the end it doesn't matter. Water is wet and it wets other things,
what
and it
about
doesn't really
OH?
matter how you define
Does
it.
it matter for
Yeah.
OH?
Pardon?
Does it matter for OH?
So OH minus is what bases make. It is
Oh.
the, it is
But
so
it's not a base itself.
consider it the strongest of all bases. Sodium hydroxide is a strong base because it contains hydroxide.
Okay.
And the part where students get confused is they go, oh, it's not a base. I guess it doesn't react with acid, which is like the exact opposite conclusion you should be making.
Okay.
Yeah.
If it always has to add to 14, how do you get like pHs above 14?
If two numbers have to always add to 14, and let's say one of the numbers was 15, what's the other number?
Well, yeah, but you can't have negative adds.
You
amounts
can't
of
have
acid.
negative.
You
What?
just have a larger than, because it's to the negative.
Yeah. You can have a
15,
pH
so
of.
you just add it with like 10 to the 1.
Yeah.
Something with 10 to
Now
the 1.
you have a pH of negative 1. pH of negative 1s are possible. It's 10 molar.
Oh,
Yeah.
triple.
Yeah. So the scale isn't arbitrary, and it doesn't. So we didn't pick 7 because it was convenient. Because a lot of scales, like why is the Celsius scale 0 at that point? It's because, well, that's because water freezes, and that was convenient, and we just said that. But that's not the real 0. The real 0 is when the molecules stop moving, and that's why we have an absolute 0. But the 0 for pH scale is an absolute pH. It is in the middle when there's the same amount of acid and base. And so that wasn't picked arbitrarily. Humans didn't look at it and go, oh, that's convenient. It just happened to be convenient. It could have been anything. Slightly different world, slightly different chemistry. It could have been like, instead of being 7, it could have been like 6.5. In fact, if you heat water, it becomes more acidic and more basic. So the pH of neutrality of water is at room temperature water. If water is, say, at 50 degrees, the pH, neutral pH might actually be like 6.8. It will be more acidic and basic.
If they're both more acidic and both more basic, should they still be equally more acidic?
Yeah, but they're, the only thing that changes in equilibrium is temperature.
Yeah.
And so the number amount of H plus to AOH minus here, this is like way beyond what I need to tell you right now. But you'll do it later, so why not? This Ka here, that is 10 to the 14. If you heat water up, that becomes like, instead of 10 to the minus 14, this is a, hold it, which way does it go? This is a endothermic reaction.
Really read it.
So when you go that way, it shifts more to that side,
Means it gets bigger.
and it gets bigger. And so it's not 1 times 10 to the minus 14, it's now 5 times 10 to the minus 13. And so the middle point literally changes. Some tricky, not really tricky, but exam questions both in this class and definitely for AP will be, you heated up water, you calculate pH, is it acidic, basic, or neutral? And then they'll say, what happened to the concentration of H+? And that's intended to lead you down the garden path of saying, oh, it went up. The amount of H+ went up. So then you say, oh, it became more acidic. And it didn't, because there's the same amount of hydroxide, so it stayed neutral. But if you realize that, then when they ask you what happened to the amount of H plus, you go, oh, it stayed neutral, so nothing. And then no, it increased.
So it's neutral, but the pH is.
But the pH is different. Calibrating pH meters at different temperatures and different amounts is like the most pain in the ass thing you can do in a lab because they are incredibly sensitive. Water is everywhere and doing everything. I keep wanting to get up and run to the board, and I can't because I am stuck here. Okay, conjugates of strong acids and bases. That is enough.
Can you convince them to buy you a TV?
I want a TV back. But, I mean, this is the first time it's been borrowed all year. I can't really complain. I want you to write all the conjugates of the strong acids and all the conjugates of the strong bases. I'll do the first one for you.
Don't do this to us, please. I just want to go home.
This is in like 2 weeks. Stop complaining.
Fine,
You're
it's almost
musical.
spring break.
Once
It's
you're
spring
done musical, you have like all the free time in the world. You
break.
don't
I
have
wouldn't even
arts
have
anymore.
I wouldn't even have arts. So.
You were wandering around saying, I beat the system.
I was wandering around saying I beat the system. The system beat me, honestly. I sold my soul to musical.
Okay, CL minus, what's the next one? Just call it out.
ClO4 minus.
So he beat the system.
I sold the system.
I minus.
The devil. I sold my soul to the devil. I literally did.
ER minus.
I
NO3
sold my
minus.
soul to the devil.
Why not, Nicholas? You're single-handedly saving
HSO4
the class.
minus.
Pardon?
HSO4 minus.
I sold my soul to the devil. Really?
IO minus. Or 3 minus.
IL3 minus?
Yeah.
H2.
What's going on? Why is there so many?
I have to double check that one.
I was just gonna say.
I always,
Strong acids.
IL3 minus is not one. It's below.
Oh, like it has to be in there? Well, then
It
we've
has
done
to
all
be,
of them.
it has to be in here.
Well, we've done all of them.
Yeah. But that's why I was confused. We weren't calling out randomly.
Oh.
So, those are all the conjugates of the strong acid. What are the conjugates of the strong bases?
OH
O2.
minus.
OH minus,
NH3.
NH3.
That's it, right?
No, there's actually some more.
O2 minus? Wait, no.
Nope.
That's basic stuff.
If you have Na plus OH minus, and you know, you got it from NaCl, sorry, that arrow should be going the other way. What's the conjugate of that? What's the conjugate of NaOH?
Water.
Like,
What the hell is it called?
if that goes this way,
Is it NA?
it's Na.
All the alcohol.
Can this ever go, can Na ever react with hydroxide to become sodium hydroxide solid? No, it's too soluble. So all of the alkali plus as ions will not affect the pH of your solutions. They're neutral. But, well, pH, I'm aligned a little bit. These conjugates of strong bases are infinitely weak acids. Will never drop the pH. And these conjugates of strong acids are infinitely weak bases.
I don't get this.
Will never react.
I thought it was
So Dylan,
yeah, I don't even know what a conjugate
if I
is.
have HCl,
Yeah.
that we did conjugates last day, so you gotta go back in here and redo it.
Okay.
But I will do a conjugate thing below
Oh,
here
is that
anyway.
like the product of like?
Yeah.
Okay, yeah. Okay.
But if I have HCl, what does it become?
H plus and Cl minus.
And if I wanted to be really grade 12-y about it, I would go like this.
Okay, yeah.
But those are the same reactions. What kind of arrow is that?
One way arrow.
One-way arrow. It is not an equilibrium.
Okay.
So since it can't go backwards, can Cl minus ever react with H plus to create HCl?
No.
So it can never be a proton acceptor.
Oh, I see.
Never proton acceptor. Acceptor. You have two fuses. So they can never act as bases. It's a bit like, you think of like a famous like movie star or somebody you know who has a spouse who is not also a famous movie star, just like a regular spouse. You don't even know their names. They don't matter. They're not Mr. or Mrs. or name. They're not. Their name's not Joe. They are husband or wife of name of famous person, because that's the only way you know them. These are a bit like the conjugate of the strong acids and strong bases. They live in the shadow of their more famous partners. They can never do anything on their own.
I kind of like that. Let me find a famous part.
But they get to hang around the movie star all the time. So that's kind of cool. Yeah.
Can't like, don't the partners of those famous stars have like the most freedom though? Because they have like.
Okay, this is the difference. I used an analogy that is not real. All analogies and metaphors break down when you examine them very closely. DNA is not a blueprint, or a computer code, or a set of instructions, or a recipe.
It's just DNA.
It's a series of chemical reactions that occur when an enzyme approaches it. And what happens is mostly an accident.
An accident?
Well, all of that happens because of enthalpy and entropy. There's nothing that the enzymes are doing what they're doing because they happen to have been made by something that happened to, like, it's just, once RNA started replicating, it's an algorithm. I think now it's actually easier to discuss because we know what algorithms are. When you have an algorithm on your feed, we know that sometimes people mess with that and they make different algorithms. But an algorithm just reacts to you. It's not intelligent in and of itself. It's just reacting. DNA just reacts to the environment based on what mutations it gets. It is not because a recipe implies that someone made it for a purpose, whereas we have tons of really weird, crappy stuff in our DNA that work mostly by accident. The fact that we are lactose tolerant is wild. At some point, we took our lactase gene and some groups of people multiplied it throughout their genome. You have like 5 or 6 lactase genes. And when you're a little baby and you're, suckling on your mother and you're drinking milk, it's on for everybody. It's very rare to be lactose intolerant to your mom's milk. Very rare. That would be, in ancient time, a fairly quick death sentence. So most people are not lactose intolerant at the time. And then once you wean and you stop drinking milk, your body goes, oh, you don't need that anymore, and they shut that gene down. But at some point, someone looked at a cow or a goat and said, or a horse, because that's also another thing, and said, I'm going to drink that. And they got sick. They did get sick, but it did provide some calories. And there was a variety of cooking techniques you can do to decrease the amounts of, a lot of cheeses will decrease the amount of lactose. So there's a lot of complicated things you do to make it more edible. And at some point, somebody's genome duplicated the lactase gene and one shut down and the other one didn't. And that just stayed on by accident. And now they could digest milk, and now they have access to an extra nutrition source. If that mutation happened and there's nobody drinking milk at the time, wouldn't have
What
survived.
time did this happen?
Ages ago. You can tell people where their genetic background is by the percentage of people and how long they've been cultivating cattle, by what percentage of the population is lactose intolerant.
So I can drink milk, so where's that?
Yeah, but the thing is, you have like 6 or 7 of those. Your ability to drink milk can shut off when you're like 32 and you're now lactose intolerant. So they turn on and off randomly. You can be lactose intolerant and one will turn on when you're 12, but you've been lactose intolerant since then. It turned on, you don't know, and because you don't eat it often, it doesn't make very much, and so you'll still feel sick if you eat it. So you'll never know.
I feel like you're assuming lactose intolerant people just don't constantly.
Wait, so we were never-
Actually, I do now live with someone who's lactose intolerant, and Ms. Walensky sometimes eats more cheese than I've ever seen anybody eat in their entire life. At other times she'll say no, so I don't know what goes on, but I do know that people are willing to put up. Cats, all cats are lactose intolerant. When you are feeding them a bowl of milk, you are not doing them a favor. You are giving them really bad diarrhea, like really bad. Yeah. If they're a wild cat, you might be starving them. because they will diarrhea out all the regular food. Yeah.
Once had a friend who was like constantly sick, and when they came to school, they were like, "Oh, I figured it out, lactose intolerant." I'm like, great. And then like a month later, I was at their house, and I watched them put yogurt, ice cream, and Cheetos into a colander.
And Cheetos?
Yeah, it was very concerning.
I was gonna say that's really gross, but on the other hand, now I really want to try that.
No. And I was like, wow, this is what we're doing. And they were like, yep.
Yeah. Okay. Okay.
Are you lactose intolerant? They're like, nope, I am.
That was a huge aside. I'm sorry. I did not mean to go into biochemistry. Weak acid, weak base. To compare it, look at Taylor, Eshwan.
Untie my shoe.
It's a strong acid and a strong base. Eshwan, 100% ionized. Weak acid, weak base. Not 100% ionized. Nice. Write equations to show what happens when a strong and weak acids and bases are dissolved in water. Dissociation and ionization. We've kind of already done that. For a strong acid, let's just write out some strong acids. Let's do HCl plus H2O, H2SO4 plus H2O. Name a strong acid. HI plus H2O.
HBr.
Nope, we're gonna stop there. I ran out of room. What? Sophia? Question? Comment?
No, we saw this. I saw this and I was like, oh my.
Oh, well, I'm glad I brought you joy.
It really made my day.
Weak acid.
That was so
Let's go HSO4 minus because I want to. What did you say? NaOH? What?
Wait, no, I'm sure.
No, weak acid. You're
I'm thinking more.
HbO4 2 minus. H2CO3. That's an important one.
You can use H2O.
And I just did all that wrong. What am I reacting them with? Water.
Wait, then so you can't use H2O then?
Sure you can.
Then H2O plus H2O. Oh, right.
Please do that. Although that one's special, so I'm going to cut it off. And for this one, we must use two-way arrows.
That's true.
Do they all get 2 arrows?
They all get two-way arrows. Well, not these ones. Those ones.
Oh, okay.
And then write them out.
H2O plus H2O.
Yeah, H2O plus H2O. It's a little bit of I am my own grandpa, but
It's become H2SO4
You said it's a little bit
for the first one.
pardon?
It's become H2SO4
Can it?
because the H2O gives a proton one.
Does it? What are we writing here?
We got it.
Right. So if you do that, what have you made?
A base.
Right. And can that ever be a base?
Yeah.
Can that ever be a base?
No.
No.
Water and water. What if that just
Wait,
makes
go
more
back,
water?
go back.
No. Water will not just have more water. Not always.
It's like if I have a glass of water and I pour more water.
And so
into
water
it,
will give it.
It's just gonna be extra water. Like,
No, this is happening in the water. You don't need to add more water. This is one water molecule and another water molecule. You don't have to add glasses of water. Glasses of water have lots of water molecules.
I'm so okay, but it's water. Yeah, they don't.
Wait, is that what it turns into?
Like if I just put some
No,
water
no,
in
that was what you thought it turned into. That was wrong.
Oh,
We established that was wrong.
oh, it's
Bro.
It's an acid.
So it turns
You should
into,
not be making hydroxide when you're dealing with acids.
What's it turn into?
It turns into HBO.
It gives away the H.
Yeah. Gives away
HBO,
the-
right?
So what does HCl plus H2O make?
I'm done writing.
H3O plus SO.
H3O plus
The online.
CO9. What does H2SO4 plus H2O make?
HSO4 minus plus H3O plus.
HI plus H2O makes?
I minus plus H3O plus.
Yeah. And the main part of these ones, one-way arrows.
Keep it up.
Luca,
So
question?
satisfying.
No, I answered it. Everyone answered it.
Next one. What would that one make?
SO4 2 minus plus H3O plus.
Yeah. So it cannot make hydroxide because I've told you we're doing acids. And we know it can never act as a base. As Felix pointed out, it is a conjugate of a strong acid. So it will never act as a base. It cannot go backwards. Next one. Volunteer.
PO4 minus 3 plus H3O plus.
Next one. Someone else?
HCO3 negative plus H3O plus.
Last one.
H3O plus plus OH minus.
And that happens, the KQ for this, or I'm going to call the KA, is equal to 1.0 times 10 to the minus 7. So that is in all glasses of water. Dylan? All glasses of water.
Wait. Hold on. HCO. Wait. H3O. Okay. So technically, when we pour extra water into the glasses that we have,
It already was that.
KA or
Oh.
KQ?
KA.
so technically they've lied. We're not even drinking H2O. They like literally lie.
And notice this is written with a KA because it's an acid reaction, but it's also a base reaction.
Then we're not drinking water if it's not that.
You never drink pure water. Will have a pH of 7, pure distilled water that is sealed from the atmosphere. Will have a tiny bit of H plus and OH minus.
How do
However,
we drink one H2O?
pardon?
Can we drink one H2O?
One H2O? You can't drink it because you wouldn't even notice. It's one molecule. You wouldn't even notice you're swallowing it. You're breathing that.
But what if?
Be a gas.
Oh.
Now, there's other things in your water though. If you have water and you just take a glass of distilled water, freshly distilled, it's just got this in it, and you just sit it on the counter for an hour or two, what's it reacting with in the air? Oxygen, CO2, nitrogen. And there's one particular reaction that it does. See, as CO2 dissolves, that makes, and what do we know that this is?
Bad.
It's an acid. So H2CO3 breaks down into H plus HCO3. This is also a weak acid. You theoretically could have HCO3 minus plus H2O goes to H3O plus CO3 minus 2. Now this one, not nearly as likely, but this is definitely going to happen. And that is why our oceans are becoming more acidic because the amount of CO2 in our atmosphere is going up. And that is shifting this equilibrium to the right. And
That's my
this
research essay topic.
is a very, very unstable acid. It's not 100%, but it likes to go there. It breaks down very quickly and does this equilibrium.
So the volume, so there's less water in our oceans.
Well, it's not that there's less water, it's that our water becomes acidic. And at some point,
But there should be less H2O molecules in our water now.
yeah, but we're not talking like liters of it. We're talking that some ions are dissolved in it. We're talking about a pH going from like 7 to 6.3
No,
and going from 6.3 to 5.8. So, and the actual physical stuff hasn't gone anywhere, so you wouldn't notice like a volume decrease or anything.
Yeah, but if CO2 is going up, then H2O should go down, right? 'Cause the equilibrium.
Yeah, but the H2O is still here in this. So volume-wise, it's the same. It's absorbed some carbon. That carbon is reacted with some of the water. So yeah, absolutely, some of the water's gone. But it's still physically in the ocean. I didn't know. I thought you thought it was like the atoms were disappearing. And it should be going on. One of the problems with this is that sea creatures have calcium carbonate shells, and at a certain pH, that equilibrium breaks down because it just reacts at 100% at a certain pH. It no longer has an equilibrium. The day the pH of the ocean is strong enough, low enough to dissolve all those sea creatures, the ocean ecosystem will collapse because all those creatures will die. Everything that feeds on them will die. Everything that feeds on those will die. The plants that requires them will die. That will be really, really bad for the environment. So global warming, one second. Global warming is not a worry. Sea levels rise. You got to move up a mountain. Sure, it'll hurt all the poor people, but like we'll be fine, right? Okay.
Yeah, we don't care.
If the ocean ecosystem collapses, everybody's screwed. So you don't buy a second iPhone when you already have an iPhone. You recycle, you reduce the number of flights you're taking, not because you're worried about global warming, but we need absolutely less CO2 in our atmosphere. We need to absorb it, and we need to get it out of our ocean, because our ocean is becoming acidic too fast. The chemists are far more worried than the climatologists who are worried about things like acid rain and you know, oh, it's warmer. Like, you know, the physics, the chemistry of the ocean is a far higher concern. Your hand is up. Ages.
Wasn't there an incident where someone tried to make it more basic and like poured it in somewhere and then it killed things?
What about your baking soda?
Wasn't there like a thing?
Yeah, they did. And off the coast of British Columbia, someone took a giant freighter full of like iron shavings and powder and just dumped it in the ocean. And what that caused, because it's a micronutrient in short supply, it caused an algae bloom. So all this algae grew, and then because there's no more iron, it all dies and sinks to the ocean. When algae grows, it's sucking CO2 out of the ocean and from the atmosphere. And number one, they didn't experiment without telling anybody. They did it off our coast. We don't know what other effects it's going to have, but obviously someone was worried enough, they just wanted to try it to see what it was due. And it had to be someone fairly major. Nobody has a lot of time, energy, and money, and ability to keep it secret enough that we still don't know who did that. So someone did an experiment to see, can we suck CO2 out of the air, but with algae blooms, which are highly toxic to sea life, because they also take up all the oxygen out of the area too. Yeah. So it's not like a great solution, because things in the ocean still die. Yes?
Why hasn't this been talked about more in terms of like global kind of conversations? Like,
How many people, other than in this room, that are adults in your life have taken Chemistry 12?
good point.
And then, in that subgroup, which would include doctors, how many of them remember Chemistry 12?
Why wouldn't someone?
Global warming,
I was gonna say, why can't like people why can't you have a chemist go on and explain what is happening, but then people won't lose it?
Bill Nye literally went on television, lit the glow ball on fire, and swore at everybody. Lit a globe on fire and swore at
Talking
everybody.
about ocean
That
acidification.
That was a great video. But like scientists have been complaining for a long time, but we use cautious language because of course nothing's 100% true.
Can we
And
watch?
the public doesn't just believe people who say, hey, I published a paper, this is concerning. They go, if it's that concerning, the government will create a law.
Next class we watch.
And we're going to vote for someone who doesn't because I don't believe it. Hold it. What? Why are you getting up? We could do more. Yes, we could.
30 seconds of
30 seconds.
Everyone has a question.
everyone has a question.
Yes, Eshwan, go.
Can you go to the page behind this for a second, please? I need to see the last example for the strong acid.
Clever.
Up for strong acid. No, up, strong acid. Yeah, 1 second. No,
Oh, that was very clever. Because that took us down to 2 seconds. Well done.
Oh,
Well done. Well done.
I wrote it down right now. I literally had to see
Well
it.
done, Ishwan. Clever. 11:45, you done? Excellent. Good job.